Now that we know how to reduce integers, rational numbers, and radical numbers, it's important that we learn to reduce polynomials. The good news is it's super duper easy. It's almost as easy as reducing integers. So a polynomial number, we know, is a number that looks something like, say, 36x squared y. So that's a polynomial. It could have just one variable. It's not required to have two. It's not required to have three. There's no real number requirement, except there should be one, at least one, to make it a polynomial. So let's go ahead and reduce this monomial first. So we're going to start with monomials, which are the easy ones to reduce. In fairness, I should tell you that when we get to higher order polynomials, which we'll talk about in a minute, they're not as easy to reduce, but monomials are as easy as integers. So if I do the factor tree, right, we're going to do the hockey stick. So 36 divides by 2, leaving 18. 18 divides by 2, leaving 9. 9 divides by 3, leaving 3, and 3 is prime, so we're done. So the integer part, not a problem, or the number part of the polynomial. You have 2. Well, let's use exponential form because we don't need a products of primes. If I said product of primes, you'd write 2 times 2 times 3 times 3, but I'm going to go with exponential form. Is 2 squared times 3 squared. Now, if you look at the variable, it's already in exponential form. So this would be 2 squared times 3 squared times x squared times y. Done. How easy was that? Let's look at the product of primes, though. So this is the exponential form. And now we want to see it in pop form. Well, that's easy enough, right? We just work our way down the hockey stick. So we have 2 times 2 times 3 times 3. Now, exponential form isn't going to work for the variable anymore. But what does it mean, x squared? It simply means x times x, right? So 2 of these. That's what it means to be squared. And then times y, and there's only one of them. Easy enough. Let's do another one. Let's do, let's see, 46 x cubed y squared z. We're going to write it both in exponential form and in product of primes form. I should label that for you. That's POP, or product of primes form. Okay, so let's do the number with the monomial that we have. Let's go ahead and reduce this. So 46 divides by 2, leaving 23, which is prime. So easy. So let's write the product of primes form first this time. So 46 is 2 times 23, both prime numbers. Then x, I need 3 of them. 1, 2, 3. Y, I need 2. Y, or 1, 2. And z, I only need 1. So this is the pop form. And then the exponential form would say 2 raised to the first power, which I don't write a 1 when I have a first power, times 23. Hang on, I have to erase that. So 2 times 23 times x cubed times y squared times z. And this is the exponential form. Okay, so that's easy peasy. Now we want to start talking about polynomials as polynomials rather than only monomials. So if you know that a monomial is a polynomial with one term, what do you think you might call a polynomial with 2 terms? First, what the heck is a term? Okay, well, let's write something down. Well, I think a polynomial with 2 terms is probably called a binomial. In fact, it is binomial, meaning a number with 2 parts. right? So bi meaning two, and nomial meaning parts. Actually, nomial means number, but in translation something gets lost, so we're just going to call nomial parts. Okay, so but it does mean number. So an example of a binomial is like 2x squared, that's a monomial, but I want two parts. I want two monomials. Right? So maybe we should take out the word parts and say a binomial has two monomials, and then it fits the nomial word. 2x squared is a monomial, and if I add to that another monomial, 3x. Now what I have is one number that has two monomials. That's a binomial. A trinomial is one number that has three monomials in it. So let's write an example. 3x squared plus 6x plus 8. Wait a minute, we haven't been calling 8 a monomial, have we? But remember, 8 could be a monomial if we had an x that was defined so that 8 is a monomial. So we're actually okay with 8 being a monomial. Now you don't want to throw an x in there because it's not part of the number. And we'll go into greater detail about the variable and the power and how we convert 8 or talk about 8 as a monomial. We're going to talk about it more generally right now. So let's look at this. If this is a term, right, this is an x squared term. That's what we call that. This is an x term, right? It's a term that only has x to the first power on it. And this one has a special name. Until we start talking about it later, we're just going to call this the constant. Right, so that's the constant term. So let's do a couple more examples. What if I have 3x cubed y plus 2y squared plus 9x plus 6? Okay, these are four monomials, or it's a number that has four monomials in it, and so it's a okay, so we would call it a quaternomial, but that word is very unwieldy. We don't really tend to say that. We say it's a four-term polynomial. And let me move that. I'm sorry if you started writing already. It's harder for you to move things than me because I have this electronic version, but there you go. So we're going to call this the x cubed y term. Notice how we don't care about the 3 when we're naming the term. We care about the term only based on the variables. This is the y squared term. This is the x term. These should all have dashes, by the way. And this is, do you remember the name of the one that doesn't have a variable attached to it? Constant term. Okay, so that's what a term is. A term is the monomial that has a plus or a minus sign in front. And I haven't given you any with minus signs, so let's do one like that. Well, let's not. It's just divided by a plus or a minus sign. That's what a term is. Okay, so now let me write a different one. I'm going to put minuses in this time. So 3x squared plus 2x minus 2x squared minus x plus 6. All right, so let's look at this. Our instinct is to call this a 1, 2, 3, 4, 5-term polynomial, but we would be incorrect. And the reason is, notice that some of these are alike, right? This and this are alike in name. They're both x squared terms. So we call these like terms. And we call them like terms because they're alike. based on their name, the x squared term. Same thing here. We have a 2x and a minus x. So these are alike. These are x terms, means they're alike. We're actually not going to say alike, we're going to call them like terms. Okay, so those are like terms. In order to determine the kind of polynomial it is, we have to combine our like terms. So that's a process called combine like terms, or CLT, because nobody wants to write combine like terms 95 times. So let's go ahead and combine like terms in this polynomial. So we've already talked about 3x squared and minus 2x squared are like terms. So let's put them together. 3x squared minus 2x squared, they're alike, so I'm going to put them together. This is called regrouping. Then I have a plus 2x and a minus x. Notice how I'm taking the sign. The minus sign went with the x and the other minus sign went with the minus 2x. The sign goes with the term. The plus went with the 2x because that was what was out in front. So the sign always goes with the term. And then I have a term that's not alike anything, it's all by itself. Plus 6. Okay, so let's combine. The only terms you can combine are the ones that are alike. How am I going to put 3x squared and a minus 2x squared together? Well, this is where the coefficients, there's a new word. These double underlines, these are coefficients. Right? The coefficients are the numbers in the front of the variables. So in this case, I have a coefficient is 3x squared and a coefficient of minus 2. Remember, the sign always goes with it. In the second case, I have a coefficient of 2 and a coefficient, look at this. Do I have a coefficient here? What's the number in front of here? If I had to write a number, what would it be? It would be a 1. And I'm going to do something a friend of mine used to do. I'm going to dot it in, right? Because it's an imaginary 1 that you don't actually have to write down unless you need it. And then 6, what's the coefficient for 6? Well, there isn't one because remember, 6 is a constant. It has its own name. It's not a coefficient, it's not a term, so it's not a coefficient to a term. It's a constant. Okay, so let's go ahead and start combining. I have 3. Now think about this. X squared and x squared, these could just be green marbles. I have 3 green marbles, and I take away 2 of my green marbles. How many green marbles do I have left? Well, I have only 1. And I can write the 1 in front if I want, but I don't have to, so I'm going to write the dotted one. It's an option. So 3 green marbles minus 2 green marbles is 1 green marble. How many? Now these are yellow marbles, right? So I have 2 yellow marbles and I take 1 away. How many do I have left? I still have 1 yellow marble. Keeping careful to make sure x squared is my green marble and x is my yellow marble. And then my constant I'm just going to bring down because it's just a constant. And so now I have combined my like terms. Let's do an example or two. So let's see, 2x squared y plus 3x squared plus 2y minus 6x squared y minus x squared. Okay, let's go ahead and regroup them, okay? So I have an x squared y term here, and I have a minus 6x squared y term here. So let's put those together. 2x squared y minus 6x squared y. Done. Now I have an x squared term. Do I have any more? Oh, I do. I have one here. So I have a plus. Remember, the sign goes with the term. 3x squared minus x squared. So I've got my 3x squared term and my minus x term, or I've got my x squared term and my other x squared term with the coefficients that they're defined by. And then let's use a different color. How about purple? I have a 2y term plus 2y. Okay, I've regrouped them so that they're all together. My like terms are together. And now let's combine them. Well, this x squared y is really just like a green marble, right? That's the thing that's the same. I have 2 green marbles and I take away 6 of them, which basically means I give away 2 and I borrow 4. So I have negative 4x squared y. And then my yellow plus, well, I don't even know if it's a plus yet. I shouldn't jump the gun, right? Because it might end up being minus. So let's do the arithmetic first. I have 3 yellow marbles and I take away 1, so it is still positive. I'm left with 2 yellow marbles. And then my little 2y term is all by itself, 2y. So quick review, and you're going to need to know these on the practice set, right? A term has a number and a variable configuration, x cubed, say. The number part is called the coefficient, right? The variable part is how we get the name. So this whole thing together then, and let me change my arrow to reflect that. So the whole thing together then is the x cubed term. And the only terms that are like the x cubed term are other terms that have x cubes. So I could have a 6x cubed, a minus 7x cubed, a 1/2 x cubed, any term or anything that has, or I could just have a plain old x cubed, which remember is the same thing as having that imaginary 1. So any monomial that has an x cubed in it is like or alike with the 9x cubed term. So like terms have the same variable configuration. The number in front of the variable configuration is called the coefficient. And if you have a number that doesn't have a variable attached to it, that's called the constant. And we call it the constant term.